Hello, my lovelies, and welcome to our section on valuation and risk models. It's another big area, 30% of your score, but it's not as readings heavy as book 3. Some very exciting topics for you here today. Of course, we're going to be valuing options with the binomial tree and Black-Scholes model. We're going to be seeing again our bond material in book 4. So let's get started. Okay, so this reading here, measuring and monitoring volatility. This used to be in the quants section some years ago, and it's now being moved here, I guess, to make the syllabus more consistent. The syllabus used to mention EWMA and Gauge in book 4 as well as in book 2, so they kind of merged the material now. And I guess the key point that we were making during our tuition course was that, of course, the traditional way of estimating historical volatility assigned equal weights to all observations, including younger and older data. And of course, practitioners were telling us that younger data should have more importance than older data. So that's why we devised measures that would assign exponentially declining weights to older data. So you've got EWMA, which of course stands for exponentially weighted moving average model. So know this formula, of course. It's telling me that the variance in the next period is given by the variance in this period weighted by lambda, and the return squared this period weighted by 1 minus lambda. So it's a weighted average of those two concepts. Notice here there's a nice qualitative point as well. Higher values of lambda lead to models that react more slowly to new information. Well, let's try to explain this. Well, if I increase the weight lambda, that means automatically I'm reducing the weight 1 minus lambda. And of course, the new information is what's happening right now. So the return squared today. So a higher lambda would essentially assign a lower weight to what's happening today, or today's return squared. And that's why the model will react more slowly to new information. So that's your EWMA. And then, of course, you've got Gauge, generalized autoregressive conditional heteroscedasticity model. The most important word here is the word generalized. It's a more general version of EWMA. And essentially, again, we're going to have the usual suspects, the variance today and the return today. Of course, that both are squared and both have their appropriate weights, alpha and beta. However, the difference that we see in Gauge that we don't see in EWMA is this omega letter,